Okay, this is welcome back to 2.2. This is part 2 of this section. Part 1 was about half an hour, so we took a break on that, and we are back and ready to go. So if you want discussion of these rules on the front page of our note sheets, then you're going to want to take a look at part 1. So we're going to pick it up at 49 through 58, and here we go. In exercise 49 to 58, find all the real zeros of the polynomial function. Determine the multiplicity of each zero, which we talked about as we went through a couple of these examples up here, multiplicities. And use a graphing calculator to verify your results. We're even going to sketch the graph beforehand just for the fun of it. All right, so if I set this equal to 0, I would like to be able to factor if I can, and I note every term has an x squared factor to share. So I'm going to pull an x squared out. I'm left with x squared minus x minus 20. I can further factor. We have a quadratic here. Factors of negative 20 that add up to be negative 1 would be negative 5 and positive 4. A quick FOIL check, x squared plus 4x minus 5x gives me a minus x, and there's my minus 20. Therefore, x equals 0, x equals 5, and x could equal negative 4, but that 0 is a double, or we would say x equals 0, multiplicity 2, 5, and negative 4. Now, watch how powerful this is. X equals 0 is a double 0. I'm going to put a 0 there and circle, just for a reminder. 5 is a 0. 1, 2, 3, 4. 5 is a 0. Negative 4. 1, 2, 3, 4 is a 0. This end model behavior is a positive to the fourth. Eventually, this positive to the fourth term dominates, and it takes it up to the right, up to the left. So eventually I'm passing through this 0. It's a single, so it passes through like a line and wants to head up, and steeper all the time. It wants to head up to the left as well. This is a line 0. It's a linear 0. It goes through here like a line, although it's getting steeper all the time. This 0, however, is a touch. It's a double 0. It wants to act like the vertex of a parabola at that instant. So this must look something along the lines of this. Now, I don't know how far down these go. I don't necessarily know this one goes down farther. I suspect because it has more room to go down, but I know it has this general curvy W shape to it. They didn't ask us to do that, but I want to show you how powerful that is, because what if all I really need to know is what the shape of the graph looks like? I don't really need to know all the details. Okay. Let's go to y equals, and let's get this guy in here. Clear this one, and I'm going to go x to the fourth minus x to the third, and minus 20x squared. And that's going to be pretty useless to me in this form, but I'm still going to go ahead and go zoom standard. I don't think we're going to get a real great appearance of that, although maybe enough to know what's going on here. If I go, I'm going to go ahead and zoom. I'm going to go window. I'm going to go to the left of my furthest left 0. So I'm going to start at negative, that's 1, 2, 3, 4. I'm going to go negative 5 to, I'm going to, not 50. And I'm going to go to the right 6. And now I'm going to zoom fit this. That's my zoom 0. And let's take a look. That is pretty cool that we can come up with this in a reasonably quick fashion. In fact, you give me the equation in this form, and I can get the shape of the graph, get the zeros exactly right quicker than you could enter that in your calculator and graph it. So hugely useful process for us there. Want to get very good at that. Okay, in 59 through 64, use a graphing calculator to graph the function and approximate accurate to 3 decimal places any real zeros and relative extrema. Okay, relative extrema just mean relative maximums, minimums. They'd be hilltops and the bottom of, bottom of a dip. So I think I'll put this over here. Can we see that one over here? If I get far enough away. Nope, I'm going to do it this way. It gets a little darker. I think it will show up a little bit better. Okay, y equals, clear it, negative 3x to the third minus 4x squared plus x minus 3. I'm going to go back to Zoom standard. Always a good place to start. Well, not always, but oftentimes a good place to start. And we're just looking for zeros, maxes, and minimums. Okay, now this is a cubic. It doesn't have any wiggles left in it. It's a negative. So if I want, we're going to use the graphing calculator to graph the function, approximate accurate to 3 decimals, any zeros. So here's my zero. I only have one. So second calc 0. Let's just see where all that is. Second calc 0. It asks for a left bound, so I need to get to the left of the 0. It asks for a right bound, so I'm going to make sure I'm to the right of the 0. And guess, so I hit enter. And it's negative 1.667. We suspect probably, hopefully, hey, I'll bet maybe that's equal to negative 2/3. But they're just asking for rounded to 3 decimal places, which is standard for AP math tests. And now we want maxes and mins. And here's a relative minimum right here where this graph bottoms out. So I'm going to go second calc minimum, get to the left of it, get to the right of it, and enter. Negative 0.999999. I have a minimum at x value negative 5 of the minimum value. Oh, wait a minute. X equals negative 1, and the minimum value is negative 5, if you can see that on the calculator. And then we have a maximum close to that. Second calc max. Get close but to the left of it. Stay close but to the right of it. And here we've got 0.111. So we have a maximum at x equals approximately 0.111 of negative 2.942. This one I suspect might be 1/9. Wonder. Okay, so we'll continue on. We got a few more examples here. Find a very, very important section for us moving forward in this course. In exercise 65 to 74, find a polynomial function that has these zeros. Well, if, for instance, 1 is a 0, I'm going to take you back to here. If a is a 0, then x minus a is a factor. If 1 is a 0, x minus 1 is a factor. So if 1 is a 0, x minus 1 is a factor. If 6 is a 0, x minus 6 is a factor. If 0 is a 0, x minus 0 is a factor. So it says, find a polynomial function that has the given zeros. There are many correct answers. How can there be many correct answers? I could put any constant I want out in front. I could make this 7 times x. Okay, and I think back of the book might FOIL these out, so I'm going to just FOIL this out. X times x, x squared, I get minus 6x's, minus an x, minus 7x, and I get a plus 6 for a final answer of f of x equals x cubed distribute minus 7x squared plus 6x. But technically, the way they asked the question, you would be right at that point. Now, I will give you a problem similar to this on the next test where we go through this process, and I will ask you to superfoil that out. So, If 3 is a 0, then x minus 3 is a factor. If 2 plus root 7 is a 0, x minus that, and I'm going to distribute the minus, the negative, is a factor. If 2 minus root 7 is a 0, then x minus that, and I'm going to distribute the negative, 2 plus root 7 is a 0. And technically, you were right here. I'm going to superfoil this. Now there's some conjugate work going on here, going to make this a little bit easier. Where am I going to get x squareds? Just here, x times x. Where am I going to get x terms, x to the first, without radicals? I'm going to get minus 2x's here and minus 2x's there, minus 4x. Where am I going to get x terms with the radical? I'm going to get a plus root 7x, but a minus root 7x as well, and now I'm done with the x's. I'm going to go integer times integer, that's plus 4. Integer times non-integer, this would be minus 2 root 7, but take a look. Here's plus 2 root 7, and all I'm left with is minus root 7 times plus root 7, that's minus 7. So I get x minus 3 times x squared minus 4x minus 3, and I'm going to superfoil that. Where do I get x cubes? Just here. Where do I get x squareds? I get minus 3 of them there, and minus 4 of them here for minus 7 x squareds. Where do I get x terms? I get minus 3 from the outside, minus 3, see it? And I get plus 12 minus 3 plus 9x. And how about plain old numbers? Minus 3 times minus 3 plus 9. Okay. But again, technically you're correct at that point. But it's a skill we want to have. Okay, find a polynomial function with given zeros, multiplicities, and degrees. So we have 1 is a 0, multiplicity 2. That means x minus 1 is a factor twice. 4, multiplicity 2, if 4 is a 0, x minus 4 must be a factor twice. The degree is 4. If I superfoiled this, I'd get an x squared and an x squared, multiply together x to the fourth. I want it to fall to the left, so here's a quick sketch. It's going to fall to the left and fall to the right. If I was to superfoil this one out, as it currently is, my first term would be positive x to the fourth, and that would want to rise and rise. So I'm just going to put a negative in front of that. And we could do all the superfoiling, but I'm going to leave it at that. And you may on the assignment as well. Again, this could be a negative 1, negative 2, negative square root of 7. Could be anything provided we have a negative. That makes the lead term become negative x to the fourth. All right. Sketch the graph of the polynomial by all techniques we have at our disposal other than our calculator. So apply the lead coefficient test. Well, the lead coefficient, this is a positive cubic. Positive cubics want to look like that. They eventually want to rise to the right, fall to the left. So that's just a little scratch work for me. Find the zeros. Well, for zeros, I'm going to factor out a 3x squared, and I'm left with an x minus 8. Set that equal to 0. Therefore, x equals 0. That is multiplicity 2, or x equals 8. Okay, I'm going to count by 2's here. So this is 2, 4, 6, etc. So 8 is a 0. 0 is a double 0. This graph, I'm just going to get the shape. Well, they do ask us to find some other points on here, so I'm going to at least put maybe a 4 in here, and I could calculate that out, but I'm just going to go for the general shape of it right now. I know this graph flattens out here, but I know it has to go down this way. So it's an upside down looking parabola. Here it's got to come back up and pass through this and head up. Now, how far up and down it goes, y scale, I'm not certain. If I wanted to find that out, I would do something like, for instance, maybe find f of 4, because I suspect 4 might be close to as far as this goes down. Now, that's not guaranteed just because this is 0 and 8, but it certainly gives me an idea of what my y scale would be. But the graph's going to take a look like that. Okay, that is 88. Let's take a look at 92. 92, I'm hoping this thing can factor. If we've got 4 terms, again, we're always going to try to factor something out, but I can't factor anything out. If we've got 4 terms, our hope when we set this thing equal to 0 is that we can factor by grouping. But first things first, this wants to look like positive x to the 5th. It wants to rise to the right, fall to the left. So I'm going to try factoring by grouping, and out of these first 2, I can factor out an x cubed, and I get an x squared minus 4. And I'd love to be able to get another x squared minus 4 out of that. That's the key to factoring by grouping. Can I get an x squared? I'd have to factor out 8. And if I factor out 8, I get minus 4. So this is good. I factor out a plus 8 equals 0. And now I've got x cubed plus 8. If I factor x squared minus 4 out of that, I'm left with just the x. If I take out the x squared minus 4 and the x squared minus 4, I'm left with an x cubed plus 8. So either x cubed equals negative 8, x equals negative 2, or x squared equals 4, x equals plus or minus 2. So I've got a 0 at 2, a 0 at negative 2, and a 0 at negative 8. So my other 0 would be clear over here. So this graph wants to pass through like a line. Like a line. They're single zeros, like a line. And I can sort of cheat on this, and I might be off a little bit. I do know that this, how low this would go right here, because take a look. It's going through negative 32, and at that point it wants to look like a right side up parabola. So that's actually down negative 32. Now I do not know if that's in scale with this, but I call that a global representation of the graph. We got the zeros, we got the shape of the curve, and you can check that on calculator. So more about that global representation. Here we go. Modified instructions. We can do these very quickly once we've got it down. 3 is a double 0. 0 is a triple. If I FOIL this out, I'm going to get an x cubed times, I'll get an x squared from here. I get x to the 5th and then some other stuff. Therefore, x to the 5ths want to look like this. They want to rise to the right, fall to the left. Okay, watch this. This would be part of the discussion of husband, wife, brother-in-law. But anyway, this wants to act like the center point of a cubic. So it must be coming up, and it will level off, completely level for that instant. And then it will go up. And then it has to be able to come back down, level off, and go back up. And I highly recommend you check that on your calculator. Pretty powerful. How high does it go here? Not certain. But I've got a really good representation of the shape. I know we have a maximum in there. I know where our zeros are. Okay, 104. I've got a double 0 at negative 1. I've got a triple 0 at 3. If I was to superfoil this out, I would have 1/8. I would have x to the 2nd and 3 more, x to the 5th. This wants to look like that. Eventually it needs to go up. It needs to go down there. This is a touch. This is a level and pass through. If you've seen, or we've talked about before you've seen this, if you heard the lesson on husband, wife, brother-in-law, this is somebody's coming to visit, got a knock on the door, husband and wife are home, the husband says, yeah, you can come on in, and the wife says, nope, you can't come in, there's two of them there. Act like a parabola. And then this one, husband says, come on in, wife says, no you don't, slows them down. Brother-in-law, the wife's brother says, nope, go ahead, come on in. But we do completely pause right there. We need to have that shape accurate. How far down does it go? I'm not sure. How deep is this? I don't know. Great time for you to try 108. Pause and give it a chance, or should only take you, maybe if you've got it down, should only take you maybe, I guess you could be done by now almost. Okay, hopefully this is welcome back. If I was to superfoil this out, I would have, oh wow, I would have a 9x squared here, another x squared, 9x to the fourth. This would end up being 3x to the fourth, but it's positive. It wants to look up to the right, up to the left. It has a double zero at -2. It has a double zero at add 5, divide 3, 5/3, somewhere right around there. This has to touch. It has to be coming down. It has to go back up, act like a parabola. Okay, at some point it starts coming back down. I don't know where the max min is. Maybe because this is further to the left than that, maybe the max is over on this side. I'm not sure of this. Has to come down, touch, and head back up. But a really nice global representation. How high does it go? That I don't know. Maybe I could put in 0 and find out what that is. Maybe I could put in -1. But many times for our purposes, this is enough information. Okay, so that wraps up the note packets from 2.2. There's a lot going on in here, and as I mentioned, hugely important section to your future going on. We want to become very fast and efficient at sketching these curves. I can't tell you how beneficial that is as you move on in this course, but also in calculus courses in the future. Just a really cool, powerful section for us. Good luck. Let's make certain we do not move on into 2.3, or let's make certain that you are fully comfortable with 2.2. This is not a section you want to be, oh, I'm pretty good at it. You want to nail this stuff. Okay, best wishes and stay tuned.